Okay, so now we are entering the actual small signal. We are going to study about the common emitter amplifier. We are going to derive all the parameters. And this diagram, what you see, is a simple common emitter amplifier. Can anybody say what biasing is employed here? What biasing is employed here? What type of biasing is used here in this circuit? We studied two types of biasing, right? So what biasing is employed in this circuit? What biasing is employed?
Fixed bias.
Fixed bias. It is there in the slide also. You cannot even see and say that, right? I'm not sure how many are connected to the class really, because people are so silent. An electronics class, circuits class should not go this silent. And draw the fixed bias circuit and add other components. What are the other components I'm going to add? Fixed bias circuit, you will have VCC, base resistance between VCC and base, it is called as RB. Collector resistance between VCC and collector, it is called as RC. Emitter is grounded. See, so far we did not give any input to the transistor. We studied only about the effect of VCC. Now I am going to give an AC signal as input to my base. AC means I am going to give a sine wave. So in order to couple this sine wave effectively into the base, I'll be using a capacitor C1 at the input side, C2 at the output side. So C1 will couple the AC signal effectively into the base. C2 will couple the AC signal effectively from collector towards the load. So these two capacitance are called as coupling capacitance, C1 and C2. Remember, you there is no compulsion that you should use C1 and C2, but if you use C1 and C2, the effective coupling will be achieved between the input and output of the amplifier. So other than this, I am not adding any external components. I am just adding two coupling capacitors. If required, you can add a load resistance here. You can add a load resistance RL here if required. Otherwise, you can directly take the output from C2. So this is a simple common emitter amplifier which is going to use the fixed bias to stabilize the Q point. Okay, so this is your DC circuit. So now I am going to draw the AC equivalent circuit. So remember, this is very important step. Please understand what I am saying now. From this transistor circuit, I need to draw the AC equivalent. For drawing the AC equivalent, whatever first step is, whatever power supply you have to ground it. So here I'm going to have an voltage source, right? So I'll be grounding the voltage source. And whatever AC components you have, so here resistance is going to be constant, right? So whatever AC components you have, I'm having the capacitor C1 and C2 additionally, right? I am going to short circuit all the AC components. So two things I'm going to do. First thing, I'm going to short circuit my power supply. Second thing, whatever additional components I have connected which are AC in nature, I'm going to short them. So if I apply these two things, I'll be getting my AC equivalent circuit. So the next page you see, this is my AC equivalent circuit. You see here, input side I have shorted the capacitor, and RB is connected between VCC and base, but VCC is ground because of drawing the AC equivalent circuit. So RB is between base and ground. See here, RB is between base and ground. Okay, RC is between collector and VCC. VCC is grounded, so RC is between collector and ground. See here, RC is between collector and ground. Emitter is already grounded. So this is the AC equivalent circuit. From the given circuit, you have to draw the AC equivalent circuit. From the AC equivalent circuit, you have H parameter circuit. So this is the steps you are going to have. Any doubt you have in drawing the AC equivalent circuit, if you cannot understand, please ask. I will explain it again. And without understanding the AC equivalent circuit, you cannot understand the hybrid model circuit at all. So if you have any doubts, please stop me here and ask. Anybody is having doubts? After drawing the actual circuit diagram, what are the two things I told you should do? Can somebody summarize? What are the two things we have to do for drawing the AC equivalent circuit? What are two things you should do in the AC equivalent circuit? First thing, remove the power supply or ground it. Second one, you have to short circuit the capacitors. So with that, doing those two things, I have got my AC equivalent circuit. From the AC equivalent circuit, I'll be replacing the H parameter model. I'll be replacing the H parameter model here from the AC equivalent circuit. See here the input side I have a resistance RB extra. So you will have RB along with HIE. This HIE will be coming default. Here you will have an voltage source HR, right? I'm just neglecting that because that value is very small. At the output side you will be having a current source along with the resistance RC. So this is the H parameter model. See the block given in dotted lines will come for all common emitter circuits. Other external components will be drawing it outside. The RB is conducted externally, so it will come outside. RC conducted externally, so it will come outside. Other things will be coming inside this dotted block, which will be coming default for any common emitter H parameter model. Current II is the input current, IB is the base current, IC is the collector current, and I naught is the current flowing through the load RL. I already told you the current will be flowing towards the junction, and I measure V naught across RC. Okay, and the current directions are shown here. Any doubt in the H parameter model? AC equivalent circuit using H parameter model. In this third diagram, any doubt anybody is having, please get it clarified now. The same drawing again and again for all the different biasing circuits. So if you're clear in this, all other biasing circuits should be very simple for you. Any doubts you have in this third diagram, how to draw the H parameter model from the AC equivalent circuit? If you're silent, I'm going to assume things are okay and I'm going to proceed.